Hi friends, welcome to Alpha Mathematical Institute, Avadi, Chennai. Now we'll look a problem from real analysis. Directly we'll move on to the problem. Let f belongs to set of all continuous functions defined on closed interval minus 1 comma 1. Evaluate limit h approaches to 0 1 by h into integral minus h2 plus h f of t into dt. Okay, so actually f is a continuous function defined on the closed interval minus 1 to 1. We need to find out this limit h approaches to 0 integral minus h2 plus h f of t into dt. Okay, so let us calculate this limit. So limit h approaches to 0 integral minus h2 plus h f of t into dt. This limit can be rewritten as limit h approaches to 0 integral minus h2 plus h f of t into dt divided by h. Okay, so if I directly substitute h equals to 0 here, I'll get integral 0 to 0 f of t into dt. Okay, so value of this integral is nothing but 0. So in the numerator I'll get 0. When I substitute h equal to 0 in the denominator, I'll get 0. So I'll get 0 by 0 form. This is indeterminate form. So we have to use the L'Hospital rule. So that means I need to differentiate the numerator separately, and then I need to differentiate the denominator separately. Okay, so here I am differentiating the numerator with respect to h. So d by dh of integral minus h2 plus h f of t into dt divided by, I need to differentiate h with respect to h, dh by dh. Okay, so by using the Leibniz rule of integration, we can get, first I need to substitute the upper limit h for the integrating variable t. That means I'll get f of h, and then I need to differentiate the upper limit with respect to h. That means dh by dh minus, I need to substitute the lower limit minus h for the integrating variable t. So I'll get f of minus h, and then I need to differentiate the lower limit minus h. So d of minus h divided by dh plus integral minus h2 plus h partial derivative of the given function with respect to h into dt. Okay, so from this I'll get this quantity is nothing but f of h. This is dh by dh, that means derivative of h with respect to h, it is 1. This is f of minus h into derivative of minus h with respect to h, this is minus 1, and then next in plus integral minus h2 plus h. If I differentiate f of t with respect to h, it will become 0 because this is a function of t alone. So if I differentiate with respect to h, I'll get 0. So once I integrate the 0 function, I'll get this integral as 0. So this integral value as 0. Right, so finally I'll get limit h approaches to 0 f of h plus f of minus h. Since this f is a continuous function, we know that limit h approaches to 0 f of h is nothing but f of 0. So instead of that I am substituting f of 0. This is nothing but f of minus 0. Okay, f of 0, f of minus 0, both are equals to f of 0 only. So this is 2 times of f of 0. Therefore limit h approaches to 0 1 divided by h into integral minus h2 plus h f of t into dt is equals to 2 times of f of 0. So the correct answer to this question is this answer, 2 times of f of 0. So for this type of videos, please subscribe to Alpha Mathematical Institute. Thank you.